name's David Hinojosa, Senior Captain Jenkins, Stage 24, Houston Fire Department. At our last Space City Fools meeting, we covered the topic of how to spot a bad roof. It went along as anticipated. There's a lot of good knowledge shared with us. I think we could have stayed longer, but Captain Jenkins cut himself off at 10 p.m. But I got the feeling a lot of guys have more questions. I personally had a few, so I'll post them on Facebook. If you have questions, please let me know. So I got a small list. I'm going to do, an interview, to answer the questions, and I'll be sharing this with you guys on the Facebook page. So our first question will be, Captain Jenkins, what is your 360 method? If you're the senior on the aerial apparatus and you've been ordered to ventilate the roof, how do you perform your 360?
Okay, if we're already ordered to go to the roof, my crew already has assigned jobs, so they start completing those tasks. I do the 360 by myself. I always have my Halligan. I do my 360. One thing I do in my 360 is I make sure that the secondary means of egress is established. Meaning if they're going to make their attack from the front and I have a rear door, I'm going to make sure I force that, do a quick search right inside the door, reestablish the door shut in case they're going to use PPV and not to disturb ventilation. By that time I come back around, I expect my crew, they're going to most of the time, my EO's responsible for setting the ground ladders. He decides where to set the ground ladders. And by that time, the ground ladders should be set and my crew's waiting for me. Now I say that, I have had 3 guys at one time on ladder 46 with me that had the green light to go to the roof before I got there because they had so many holes under their belt and they made good decisions. But for the most part, I'd expect my guys to be waiting for me to complete my 360. When I get back to where they've decided to ladder the building, if I agree with ladder placement, then I go to the roof first. Let me back up. On my 360, I'm trying to determine where the fire's at, what the conditions of the fire are, and I'm looking at roof conditions. Not always possible due to smoke, but if possible, I'm looking at conditions of the roof, looking for any sag or any indications of a bad roof. When I get back to where the ladders are placed, if I agree with the ladder placement, I'm going to go up to the roof first. Our roof ladder has an 8-foot New York hook taped to it, along with a 6-foot rubbish hook. The roof ladder should already be placed, hooks out, and it should be leaned up against the roof. And when I get to the top, to the roof's edge, I take the 8-foot New York hook off the roof ladder. That's what I'm going to sound the roof with. At the tip of the ladder, I do another view of the roof, if possible. Visually scan the roof. I don't know if I necessarily would always scan it with the tick. It depends on conditions. But normally, I like to have my ladders not placed exactly where I'm going to go to the roof and cut a hole. I'd rather mount the roof where the roof is solid. And then so I get a good feel not only when I get on the roof, sounding being, with the tool being number one, most important thing we can do to determine if the roof is good. And when I say that, we're talking about decking. So right before I would get off the ladder, I would initially sound the roof. Now when I step off of the ladder, I get a second feel that I'm feeling. That's what the roof feels under my feet. Now, you're not going to get the same feel right at the roof's edge as you'll get several feet up, because it's always going to be more solid near the eave, because that's right where your top plate is. So as I start to sound the roof in about a 3-foot arc, moving up, my goal is to get to the ridge. I want to make my way to the ridge. I'm sounding in a 3-foot arc. I'm feeling with the tool, looking for any soft spots. I'm also feeling now as the feel of the roof under my feet changes. And when I say that, in no way am I saying we sound the roof with our feet, but it's just invariable that the roof is going to have a different feel as you walk on it. And what I'm looking for, if the feel in the roof changes differently than what it felt, then that should be a red flag. And the feel of roofs varies depending on the spacing of the rafters and the decking material. But anyway, so I've really got two feels. The feel with my rubbish, with my New York hook, and the feel that I'm feeling as I'm walking on the roof.
So, but as far as the 360 specifically, you complete your 360, you're looking for the seat of the fire, where you're going to ladder the building, and the roof conditions.
Correct.
And on the roof, when you're looking for roof conditions, what are you looking for visually?
Visually, I'm looking, number one red flag of no-go is smoke coming through the shingles.
Okay.
Okay, if I have smoke coming through the shingles, that's a sign that my decking is being compromised. Obviously, if I have if I can see the rafters because of the sag in the roof, that's a bad sign. Those are probably the two primary. Any kind of deviation in the roof, the shape of it. When you look at a roof, normally you're looking at pretty much straight, a straight surface. And if you see the dips between the rafters, that can be a bad indicator. But primarily, it's sound in the roof with the tool. If I go up on a roof that's flat, looks sound, it can still be. I can have bad decking that I can't walk on. That's where sounding with my tool is going to show that.
So with these, if you made the structure bigger, let's say a 2-story apartment.
Okay.
Does your 360 stay the same?
On a 2-story apartment?
Correct.
I may not even get a complete 360 on something as large as an apartment. I'm gonna have to get as good of a 360 as I can, but I may not make it depending on the length of the building.
Right.
Depending on the fire conditions. As soon as you say apartments, I'm thinking truss. And one of the things with potential of truss, if there's already fire in the attic, I'm not going to cut a hole other than off of an aerial directly over where the fire's in the attic. In that case, if the fire's already in the attic, then I'm going to have to write off a certain amount to where I could get to an area of the roof where the fire hadn't made its way to the trusses. Trusses being my secondary concern next to decking. In as little as 2 minutes, you can have a catastrophic failure because of the gusset plates. And so I don't have a problem with going to a roof, cutting a hole, punching through, and taking fire to the attic, because when I do that, my time starts then. But if the fire is already in the attic, I don't know how long it's been there. So in that case, I would write off a certain amount of roof and get to an area where structurally it's still sound, the fire hadn't made its way. And there's so many variables there too, as to you can have intact fire stops or fire walls that would eliminate the advantage of cutting a hole off to one side. And then you just would have to write off cutting the hole itself.
On your 360, any of your findings that you see, so let's say you're doing your 360 and you do see some of these no-go indicators, do you relay that to anybody else in the fire ground?
Oh, well, if I see no-go situation that's going to exclude me from going to the roof,
right,
then I'm gonna radio command right away that rooftop ventilation is not possible.
Would you relay that information to your crew if you were going the route of this portion is bad, but I still got viable roof over here? We're gonna go up the viable portion, get as close as we can, and then cut there. If you're going that route, would you?
Right, we're going to communicate, and here's the way it works. My clean out person, man, always follows me with the roof ladder. This is a situation where if we ladder the building remote from where we are going to cut the hole, and so often we don't know where we're going to cut the hole until we get on the roof itself. And so if we ladder the building remote, and we're going to actually have to get to the ridge, walk down the ridge, determine where to cut the hole, then I have my roof ladder set by my clean out man. My saw man comes up last with the saw, and the reason for that is to allow us that time to sound the roof, sound where we're going to plan on cutting the hole, get the roof ladder set. When I say we take a roof ladder, I put a roof ladder and recommend a roof ladder on every single roof, irregardless of conditions, irregardless of pitch. It's there primarily as a safe haven, a place we can go to. But we put it up on every single one. Doesn't mean we work off that roof ladder. Most of my discussion, we're talking about walkable roofs. Roofs that are still sound. Otherwise, if it's questionable and we still need to get that hole established, then we're going to be working on the roof ladder itself. In that case, the sawman does all the work. The guy at the tip of the ladder is going to end up having to do all the cutting. He's going to have to do all the cleanup. If you can't move around that roof, you can't be swapping men for job assignments. Right.
So when you on your 360, you find a no-go indicator. You relay that to command. I imagine your firefighters would have heard that via the radio. So let's say you're on the Charlie side of the structure. Initially, on arrival, you wanted to ventilate on the Alpha Delta corner, but now you're at the back end of the structure. You relay it with command. It's a no-go. We cannot ventilate. The roof is roof's already sagging. So now from there, do your firefighters abort that, meet up in front? Is there a meet point after we've determined it's a no-go, or you got to just go find them and then relocate from there?
They're going to be where my ladders are.
So they wait there for you.
They're going to be right.
Okay.
If I wave off cutting the hole, then they're going to be wherever the ladders. They will have. We don't hold up pulling tools and equipment waiting on my final determination. When I get on scene, if I don't see something immediately that determines I'm not going to cut a hole, then they start moving toward that. And so then I'm going to find them where that equipment is, and then we're going to go to whatever our other assignment is.
All right. In the class, you discussed the cutting a 9x6 hole.
9x5.
9x5, I'm sorry.
That's okay.
Some of the guys were unsure as far as the method of cutting a hole of that size. And then also, some of the houses, that's nearly almost all the roof.
No, that's correct. Yeah. I mean,
so the question was, what method of cutting do you utilize?
Dicing.
So is dicing and louvering the same thing?
No, two different things. They're similar, but the difference between dicing and when you cut a large hole, a 4x8 or a 9x5 or a 9x4 or whatever size hole, large like that, you have to either louver or dice. You can no longer just make your 4 cuts with your purchase point and pull that one. It's too large and cumbersome to get done.
Right.
And there's a lot of drawbacks to doing that also. Plus, I don't believe that we should ever be cutting 4x4 holes unless that's all the roof we've got. In that case, where you talked about the size of a roof, we're going to cut as large a hole as we can get.
So you aim for 9x5.
I aim, in my mind, every time I go to the roof, we're visually looking at a 9x5. And really the 9x5 is going to vary like a 9x4, 9x5. And what I mean there is my downstroke is based on the saw we're using, an Echo saw with an average arm length on a firefighter. Your downstroke is going to be 4 foot. With the steel 461, it's going to be 5. What I try to avoid is a 6 foot or larger down cut because it's problematic getting it cleaned out. It means my clean out person has to normally move around the hole, and that means they're moving more over the roof than I want them to. I want to try to avoid as much movement on the roof as I can. It should be, if I do my job right and the roof cooperates, I'm the only person moving over the roof twice. It should be that I move over there to sound to confirm the area, a larger area than we intend to cut. Then I go back, stage my tool either on the roof ladder or hand it off to my clean out person. And then that person sets up depending on wind, direction, and of course roof. And then my saw person who I back up, a sawman, then we cut, and that person, once we finish the cut, they stage on the roof ladder.
All right, so your 9 foot cut is going atop of the ridge line.
We're talking about going along the ridge about 9 foot.
And then your 5 foot cut is coming down towards the downside of the
right.
roof.
On dicing, as opposed to louvering, where louvering you have to identify every rafter
Right.
And then you will start your cut back up to a rafter. When you finish your cut, you're going to cut to a rafter. Then you have to remember that spacing on your down cuts. And here's what happens. You have to make a bottom cut when you louver. In order to louver, you have to make a bottom cut unless it's shiplap where there's a seam every 6 inches, or if you get lucky on OSB or plywood and there's a seam in that piece. But so often you have to make a bottom cut louvering. But with dicing, you cut. When you finish the length cut you want, you make a down cut. You come over about a foot. As you get more experience with it, you can increase that maybe 14 inches, no more than 16. But say you come down a foot. Some of those will fall directly between the rafters. Some of them will louver. But you make more down cuts, but you never have to make a bottom cut.
So intentionally we're cutting small sections.
Small sections. You're dicing the roof and makes it more manageable, easier to clean out. Some of them will actually fall in on their own. Now, I will say this. If you're cutting and you're supposed to hold your hole until you get a command to open it up, then you're going to have to louver. But we really don't very seldom ever run into that. Hold the hole. Normally we have engine crews already actively trying to fight the fire.
Right, waiting for the hole.
Right, and so dicing, there's two main advantages. One, it's less labor intensive. As long as our saw's cutting adequately, it's less labor intensive. When you look at total feet of cuts, it's not much different than louvering because you never have to make a bottom cut. Mm-hmm. You'll make more down cuts, but you don't have to make a bottom cut. And you can do it in zero visibility. Where louvering, if you ever get off of your sequence on louvering, if for some reason you stop, then you have to stop and go back and re-identify rafters, and it's a time loss. But on large holes, you're either going to have to louver or dice them in order to successfully get them opened up.
All right, so louver requires more landmarks, more
landmarks, right?
Rafters for the trusses.
More visual requirements, and so often on our roofs we have limited or no visibility.
Right. And the dicing is just pretty much cut away into a piece
just
of
cut.
plywood.
Yeah.
Okay. Next question. You kind of touched on it already, but the question was, do you have pre-assigned tasks for each member of the ladder that you're assigned to?
Absolutely.
So let's start off with the chauffeur. What are his requirements?
Okay. Chauffeur's job is ladder placement, the access to the roof. His job is to decide where we're going to ladder the building. And now this is talking about if I have an experienced chauffeur, which I've always been fortunate, had experienced chauffeurs that had made many fires. So they decide where we're going to ladder based on their observation. Certainly it can change on my 360.
Right.
But his job in conjunction with, depending on if it's a 1 or 2 story, if it's a 1 story, he can do that by himself with a 16-foot roof. At that same time, the left side man would also be taking the roof ladder that we're going to take to the roof and setting it up, deploying the hooks, standing it up. So left side's in charge of ladders. Right side man is my saw man, so he's going to get both saws, which I take chainsaws. He's going to get both saws, take them up to where the ladders are at, going to crank one. Will almost always be the steel 461. The backup is the Echo. That's all we had on ladder 46. So we're going to take one to the roof, the other stays on the ground as a backup if we have a problem, and in that case it would be brought to the tip of the ladder by the chauffeur. I don't take 2 saws on the roof as a rule. As a rule, we don't have problems. Everybody has my cleanout man is going to the cleanout man. The tools that he needs are automatically every morning taped to the roof ladder that's going to be on the roof, so it eliminates his need to carry additional tools. But they'll always bring a flathead axe. My saw man will bring a flathead or a pickhead axe, and then I'm going to have one of the same. Flathead axes being hands down the best hand tool for cutting holes in all kind of roofs that I've come in.
So now the 2 guys on the right, the chauffeur and firefighter.
On the left side.
On the left side, I'm sorry, left side. The chauffeur and the firefighter behind the chauffeur are going to ladder the structure.
They're responsible for
So
ladders.
once the firefighter that brought the ladder, when he's on the roof now, is that guy your clean out man?
That's my cleanout man,
Okay.
right? He brings the ladder and then he follows me up with the roof ladder. If this is a situation where we actually have to make our way to the ridge and go decide where to cut the hole. If it's one of those situations where right where we're going to ladder the building is directly below where we're going to cut the hole, then I would be responsible to set the roof ladder. I'll bring it up just like we would. Which, by the way, I believe and teach to push your roof ladders up hooks down. I don't understand the beam. That's what I was taught, but it's ineffective, especially on Spanish tile roofs. And the flat method with the hooks up is ineffective. So hooks down, it's much easier and much more effective to make your way to the ridge when you're pushing the ladder up.
So now the firefighter B sits behind you. He brought the saws.
Brought the
One's
saw.
at the base. He's got one fired up. Does he pass that up to somebody, or does he carry it
No,
himself?
he carries that himself because the cleanout man brings the roof ladder.
Okay. So meanwhile, you guys are there cutting. What is your EO doing?
He is my ground safety man. He observes conditions from the ground and gives me a heads up on anything he sees. If we need anything additional, he would be the person we go to.
So at any point during that ventilation process, he sees something bad. Does he get on the radio and inform
Absolutely.
you, or just holler at you in the visual cue? Get off.
Either way, certainly we all know the radio is probably the least effective.
Right. Is there a
But
method you
depending-
prefer?
I'm sorry?
Is there a method you prefer?
Whichever one gets my attention. I've had both
Okay.
work. It depends on where you're at in relation to the edge of the roof. I mean, what size roof are we cutting? It's easy to imagine if we're on a warehouse or a flat roof that he's going to have trouble ever communicating with us.
Right.
I will say that I have been pulled off roofs by my EOs before. One of them now the senior captain on ladder 51, Chris Silman. Outstanding decision. In the smoke, I could not see the smoke coming through the shingles, standing up as I moved up the roof, but Captain's back then, he was my EO. He saw the smoke that I talk about, the pencil smoke coming through the shingles, and he hollered on the radio to get us off the roof. And right about that time, the smoke swirled, and I saw, and we were on a big church, and we were fixing to walk into some bad areas. If my sound on the roof had read the roof, we could have been, in fact, we would have been, because the outcome there shortly after wasn't good. But he did get on the radio.
Do you expect anyone to throw up secondary means of egress ladders?
Yeah, and I'm sorry. When you asked about my EO, he is also going to work toward getting other ladders, but he knows to try to commandeer someone that is not being utilized to get them to throw ladders for secondary means of egress. Doesn't mean it's always possible, but we quite often have people that are not being actively engaged on the fire ground, and he knows to try to get that done. But we are counting on him to be our eyes and ears from the ground.
So
as a
there
safety
he
man.
has 2 tasks assigned, and how he gets them fulfilled is up to him.
That's him.
One is you guys' safety, eyes and ears from below, and the other one is
Secondary means of egress. Sometimes a third ladder. Depends on conditions.
Right.
But he has a green light to do what needs to be done. He doesn't have to clear it through me.
Right.
But we are talking about experienced EOs.
And those are slowly dying breed.
Right.
All right. Do you have an opinion on inspection cuts?
Absolutely.
So some guys will do an inspection cut as soon as you get on the roof. And I
Right.
guess you call it a curve cut. It's a little
Right.
triangle cut.
Right.
We're checking for.
Well, it's not. Yeah, technically, I think. Okay, it's an inspection cut. Triangle cut's an inspection cut, trying to identify what kind of structural components you're dealing with.
Right. But there's for checking for structural components, you have to make a fairly large triangle to.
You need to at least go from one rafter to another, and that's the reason for the triangle cut. And then what you're trying to do, you're trying to cut it where you're not going to have to deal with heat and smoke coming out of it, because you're going to reach in there and feel what are you dealing with. If you reach in that hole and you're dealing with a 2x4, 2x4, it is most probably a truss. Not saying we don't have 2x4s on older houses. But if you reach in and you feel a 2x4, it's going to be truss construction. And so that is a quick heads up that you're dealing with trusses. But I've got to warn this, your inspection hole has got to be on toward the ridge from where your top plate would be. In other words, where the wall comes up to the roof, if you make your inspection hole between the ladder and that wall, you can they will go in and scab onto trusses with 2x6s to build their soffits. And if you reach in there and feel a 2x6, it'll give you the false impression you're dealing with full dimensional lumber, and you're not. So the only way to get a good read on an inspection cut, you have to cut that inspection hole toward the ridge from where the wall intersects the roof, if that makes sense. You have to get into the roof area itself, not into the soffit.
So, I guess average house, that space from the soffit end where it overlaps the house to the actual wall is usually about
2 to 3 feet.
2 to 3 feet.
Yeah.
So 3
Some
feet,
of them will be shorter, but somewhere, let's say 2 to 3 foot
so
average.
3 feet should be a good landmarker from the ridge, from the bottom of the.
From the ladder, what did you say?
3 feet from the ladder.
I would say 4 foot. At least go 4 foot from the ladder. Should put you back behind the wall and into the roof area where you need to be.
Right.
And that would then give you a good indicator of what you're dealing with. But that's an inspection hole. And now the place that I've really found inspection holes are necessary is flat roofs. Because as soon as I get on a commercial flat roof, well, and not only commercial, but any flat roof. Flat roofs notoriously are built so strong, they're difficult to open up. And if I get on that roof and quickly identify what I'm dealing with, it's going to tell me what type of roofing I'm dealing with. And it could be something as simple as rolled tar paper on top of 3/4 inch decking, which should open up very easily. But if I get off that ladder and I find out I'm dealing with years of tar and gravel, added on to tar and gravel, more or less dealing with an asphalt road on top of 3 sheets of 3/4 inch plywood, that's going to be much more difficult. I may need to upgrade my tool selection. I'd rather know about it early before I get off on this big roof and then find out the tools that we take as a rule are going to be undermanned. When I say that too, if I can, commercial roofs, always you have to upgrade your tools. You have to take more saws. And on a flat roof, we would carry 2 saws all the way up there. Not on a pitched roof, it's problematic because if you lose control of the saw, it comes to the ground. But on a flat roof, you're going to take more saws, more blades, possibly fuel, sledgehammers as opposed to, say, flathead axes. Not saying you won't take a flathead, but you need to upgrade your tool.
A larger arsenal to deal with
larger arsenal, and sometimes, depending, maybe additional crews, because a lot of these flat roofs can be very labor intensive to get a hole established, depending on what they're built out of. And that's why the inspection hole is so important early when you access the roof, as opposed to get off to where you decide to cut the hole and then find out what you're dealing with is something other than you thought.
But do you have any other method for what someone would call an inspection hole? I've seen some officers say they'll just use their first head cut on the ridge as their inspection cut. So as he's cutting along the ridge line, his head cut, which would be, I guess, your method, the 9-foot cut going along the ridge line.
Right.
As he's cutting, he'll see the smoke conditions that are coming out of there, whether it's black pressurized, if he's fire. That's when he's doing his, peeking there. I've seen other officers, as soon as they get off the ladder, 3 or 4 feet up, they'll make a small triangle hole, like no bigger than my hand. And again, that same officer who's doing this cut is looking for, again, just really a smoke read. Did you see any fire?
Yeah, I think it's 2 different things.
I've never seen one on the fire ground in my short time do an actual large triangular cut going over a rafter to check for what the rafter is made of.
Well, I don't think you necessarily have to go over the rafter. And my understanding of inspection cuts and the ones that I've tried to do is we cut maybe perpendicular at an angle from one rafter down till we hit the other rafter, and then make like a triangle cut,
Right.
large enough to where I can get my arm in there and feel what dimensional lumber I'm dealing with. If I feel a 2x6, and now this isn't always a guarantee, because I made a church fire that was 2x6s, but it was 2x6 truss. Again, it had gusset plates, so this isn't a guarantee. But if I feel a 2x4, I am almost 100% certain I'm dealing with trusses. It depends on the age of the building too, but I want to cut that hole. The primary reason for that inspection hole is to determine what type of structural components I'm dealing with. And it tells me what kind of decking I'm dealing with. Now here's a point. If I cut an inspection hole and I realize that I'm dealing with shiplap, I don't really have to dice. I don't have to dice a shiplap roof, because shiplap, once I make my top cut and get my shiplap started, shiplap will come off in sheets. In other words, if I make a top cut and I make my down cut and I go and make my far down cut, or maybe just split it, but I don't have to make them a foot apart, because shiplap comes in 1 by or 3/4 inch by 6 inch pieces, and as I pull one, it applies to the nails all the way across, and I have leverage, and they come off in large pieces. That's something to think about. If when I make my inspection cut, I also check the decking. Shiplap means I don't have to go through all the trouble of dicing. OSB means I have to, as normal, be aware of early failure of the roof with fire in the attic, because that's the problem with OSB. Plywood means it's going to require more energy to open up. Plywood, simply by its nature, is more difficult, stronger, but more difficult to open up. And that plywood primarily is the best reason for dicing. But then your question about the top cut, that's going to tell me more conditions. That's going to tell me, or at least when I make a top cut, what I'm looking for is what are my conditions coming through that cut. If I think I'm going to an attic that fire may have made its way in, and I make a cut and I don't see any smoke coming out, well, that tells me what the conditions are in there. If I have heavy smoke or versus fire. If I have fire coming out, then I know I have fire directly below me. But I don't think I would wait till I got to the ridge if I had a question about the structural construction or the structural integrity of the roof to make that cut. I would do that early on.
Early on?
Yeah, early on.
Is there a time you want one done versus not?
An inspection hole?
Right.
Commercial roofs, flat roofs.
So for sure, commercial or
Oh,
flat roof,
absolutely.
do it immediately.
Yes, because
If it's an apartment or a house, probably not so much.
on an apartment, it would be a question of trusses. And you know the thing today with houses, we don't know. We can have one house built exactly, two houses built exactly alike, one with trusses and one with not. That I don't have a clear-cut answer for how to identify just visually looking at a structure whether there's trusses or not. I know that
Alert, abdominal paint unit on scene.
certainly
Sign at risk. Medic 0
on a house that has a gable roof and isn't very cut up is a whole lot easier to build out of trusses, quicker, cheaper, and so if a roof is very cut up, it's less likely to have trusses, but none of those are guarantees. I have no clear-cut answer. I've never learned a clear-cut answer. So if I had a question and the conditions indicated that it could be imperative that I know the answer to that, I would make an inspection cut.
Okay. So
But-
if any doubt in an officer's mind or any member right in that position, whether I should or should not, you might as well just do
Yeah,
it.
and in all honesty, I've used my axe. I mean, the saw's coming way behind me. I'd have to wait for that saw to come up.
Right.
But I've just, and when I say that my hole is never going to be nice and pretty, but I'll use my axe and just punch a hole through the decking just enough it's easy to find one rafter.
Right.
And all I want to do is fill that one rafter. And if I put my hand in there and it's a 2x4, I'm dealing with trusses, and then that changed my mindset. But inspection holes on commercial roofs, I think it's almost imperative, because commercial roofs are built so many different methods. And one of them can be an easy vent job using a chainsaw, and the other can require all kind of different.
And lots of work.
Right, and so it's best to know that early before you get committed.
Okay. In the class, you covered if you're out of air in a structure, you can breathe through a wall space, P-trap, the toilet drain. Does that apply to all commercial? I mean, all residential structures? Somebody brought up the fact that their house was old.
Sure.
I think it was their parents' house that they bought. When they were, the house they were raised in.
Right.
Mom and dad passed away, so they took over the house. Now it's their house, so they had it upgraded or remodeled. So rather than gutting it totally for insulation purposes, they hired a company to come in and they got, looks kind of like a car wash wand. Punch the sheetrock, pull the trigger, and it sprayed expansion
foam
throughout the entire, between the two wall joists.
On interior walls?
It did the entire outer and interior. So it provided the thermal insulation for the heat and whatnot for the winter time, and then also had an acoustic factor. So,
okay. Well, what you're asking is access and air in a wall, a P-trap, and a toilet a 100% guarantee of success? Absolutely not. Like I said in the class, I've practiced all three on numerous occasions, with the exception of inhaling. I've never inhaled.
Right. So I know 46 territory has older homes that have been around for quite some time. But if you go further out west or maybe toward like 13's territory, they're redoing a lot of homes over there.
Yeah.
Should the age of the residents be a factor in, if you know in your mind, hey, I can do this method,
Well, what should be in your mind, or what are your options if you're running out of air?
Right.
It's like the other day at our class, someone came to me after the class and said that they have this ventless system, and I know they're out there, that they actually have ways now that they don't vent through the roof. They just vent into the attic.
Yeah.
And absolutely, if that is the system you ran into, then it's not going to work. But we're talking about living or dying. We're talking about having run out of air, having no other option. And so many firefighters only know go to the floor. And that isn't always a viable option. And so you have to have these as a tool. It's not a guarantee. Nobody's ever guaranteed. I mean, I've had firefighters say, well, what if the fire made to the attic and burnt through that vent pipe? Well, we're having a bad day, but if you don't know about it as an option and practice it, what about the time it would work? It's not the times it wouldn't work. There's no guarantee that any of them will work, but it's a viable option. Nobody's ever been able to disprove it not as a viable option. There are going to be situations where it will not work.
So if you did do the puncture a hole in the sheetrock, size of your mask, and now you're breathing off of it, would the insulation in there be a factor in it?
The insulation wouldn't. It depends on what type of insulation. That you're talking about, the expanded foam.
Yeah, well, I know the expanded foam would be for sure.
Yeah,
air in there.
That's no air.
Let's say you got the pink insulation was blown in.
Fiberglass insulation,
right.
You would still have some air.
So should the firefighter who's in this situation dig that piece out of insulation, or just?
Well, it probably would, if you thought you had time to dig that insulation out. I don't know that we're talking about heavy smoke conditions and you think you're fixing to die, because that's what we're talking about. I'm not talking, I would never tell somebody as a rule when, go and access this air, but we're talking about when you're running out of air, you don't know where you're at, and your option is to unplug and breathe the smoke. Then you have to have options, because breathing the smoke today is not an option.
No, you won't last long.
No, we passed this by Hazmat, who turned it over to their scientists, and they said if your option today is breathe the smoke or breathe through a P-trap or a toilet or a wall, go for those options, because the smoke is not a viable option. If you unplug and think you're going to breathe today's smoke, then you're hoping that you're found within that 4 minutes and that you're brought out and the cyano kit's applied. Because smoke today is not like it used to be. It's not carbon monoxide that's the killer, it's hydrogen cyanide along with a whole host of other chemicals. So we're not talking about a 100% guaranteed method, but it's viable options. And we have literally had firefighters throughout the country die with air in the wall right beside where they died. They ran out of air, suffocated, but never knew to try to access it.
Right.
Now, they had two options. If they'd have known that, they might have succeeded.
Might have had a chance rather than.
They might have had a chance, but they had zero chance without that.
Right. Okay. These are all the questions that I had from the class. I got one of my own. I was going to ask your opinion on a vent enter search. Do you ever
Okay.
do that? Are you pro vent enter search? Are you against it? Think it's a good idea, bad idea?
No. I think it's a great idea, and it depends on the situation. But certainly it's a great idea, especially on 2 stories and multiple story buildings. But the key, my understanding and what we've practiced on vent enter search, the key is that when you vent, you have got to go straight to that door and find a door and secure it. Because otherwise you have vented. And here's the thing to remember, wherever smoke goes, the fire is going to follow. And so if you vent a window and smoke comes out of it, you have to imagine in a certain period of time, fire is going to come out of that window. And the sooner you can get to a door, now I know in reality, so many doors that we then make our way to, you can't secure. And I know there's all kind of different ways, things that can happen that keep that. But you have to try to get to that door and secure it, which then buys you time. Once that door's shut, it's no longer have you vented the fire to that room. But absolutely vent under search. I think we probably should use it quite much more often than what we do.
So did you practice that when you were at 46?
Oh, absolutely, we practiced it.
So in that scenario, was there an assigned task for everybody?
The only 2 people went in, and first person in, which would be me, an officer, went and secured the door. The next man in started the search. But as soon as we got that search, then we would come out. When I say that, I would check the hallway. There were times, and we drilled on checking a hallway, because it could very well be that the next thing we could do is go down the hallway and check another room. Again, go to that room and get it searched, and we could go room to room to room. But again, our third man was always manning the ladder and keeping track of where we were at. And but it's something you have to drill on. You can't wait till it happens and then suddenly think you're going to go up and effectively vent enter search.
Yeah, I think that can be said for any task on the fire ground.
I'm sorry?
That can be said for any task on the fire
Correct.
ground.
Correct. I mean, we have ladders in the city of Houston right now that are tied as straight wall ladders with the halyards.
Yeah.
And I do want to talk about defogging masks. That may not be a question come up, but I'd like to address it. But no, that's something. Vests, absolutely. 51's practiced it the other day on the A shift because they drove up on a apartment fire, people trapped above the fire on the truck.
That's the second time Captain Sillman's coming.
It wasn't Silman this time, it was Stevens. But anyway, no, it's like so many things, it's viable and it has so many applications, and we don't use it very often.
Okay, what was it you wanted to go to?
Defogging the mask. I didn't get
So
to.
by defogging, you mean anti-fogging it for it doesn't fog up? Or?
Right.
Okay.
Right, anti-fogging. I call it defogging. But when I talk to firefighters all over the city and I ask how they keep what do they do when their mask fogs up, or how do they keep their mask from fogging up? So many of them indicate they turn their bypass on. They're using their air to defog their mask. The others tell me they have a magnet with a piece of felt that they act like a windshield wiper. Mm-hmm. Except that dish soap, and actually the cheap dish soap the city now will send you to the fire station.
Right.
The only thing I found it's any good for is defogging masks. But dish soap works great. It takes just a drop. And in fact, I did my mask again this morning, and a drop is probably 2 times as much as you need. But take 1 drop. I make sure that my lens is clean. I defog the inside, take that 1 drop. I smear it around with only fingertips. Smear it all around. I'll take the surplus and then put on the outside also. The outside, so when you get in there and you open a line and get steam, it doesn't. You don't get condensation on your mask. It takes probably a total of 3 or 4 minutes to defog it. I'm constantly taking my fingertips, waiting about 30 seconds to a minute for the soap to dry and trying to polish it off with my fingertips. When it gets to where it's kind of a hazy color, if you'll huff into it like you're trying to fog up a mirror, it'll clear it up and you're good to go. And I wore my mask recently on a fire on Harwin for almost 4 hours, not plugged in, but between being plugged in and being on scene, 4 hours without it fogging up. It will last, if I don't make a fire, sometimes it'll last the whole end of the second tour. But I check it every single morning by trying to huff into it. If it fogs up, I defog it.
What about the spray-in anti-fog you can buy? Say like the AutoZone for your car windshield.
Yep, I've used them. I found nothing that works as good as dish soap.
Well, I'm gonna advise if you're doing the dish soap thing to do it after shift change, because I got caught one time doing it in the morning, and I just louded that bad boy up and box drops.
Well,
so now I'm sitting there, trying to wipe the soap out. God damn it.
Yeah, no, I've had that happen too, but I can still get it wiped enough. I wouldn't advise listening to an officer that tells you not to do it because he doesn't want you to get soap in your eyes, which I just had an officer tell his guys that.
I had that happen, but it was, rare when it did happen. I was the only one sweat. If I was looking down, it would pool down there, and then when I go back up, the regulator would throw a little dab in my eye, but.
Yeah, well, ever since we got air packs, I've been defogging my mask, so we're probably looking at 36
but I never died.
years.
I never heard of anybody dying from soap in their eye.
I've never heard of it, but I have seen a lot of guys unable to perform on the fire ground because of fogged up masks. And utilizing your breathable air to defog your masks,
bad idea.
That you better be very effective at sucking a toilet.
All right, that's all the questions I have. Do you have anything else you want to add before we end? I got one more.
Okay.
Just came to me. In class, your demeanor stayed, pretty steady. I've never seen you get upset, me personally. I'm sure somebody has in the world. But then you're talking and you mentioned water supply. No, we touched on the new friction loss chart. Is what you mentioned, and you turned around, looked at the class, and your demeanor changed. That chaps my ass. And then you went back to your regular demeanor. What was it about the friction loss that aggravates you so much, or chaps your ass?
Absolutely. We got a new friction loss chart sent out from the Fire Training Academy that, first off, I don't believe the numbers I saw. I've been testing hose as long as I've been in the fire department, and I'm pretty sure of what the friction losses are on the different hoses we've gotten. And I've never, ever seen 1 3/4 with a friction loss at 200 gallons per minute of 25. I have seen it at 30, 32 Aquaflow and Pond's hose. So I get a friction loss chart, and here's what it is. This is, if there is a length of hose out there that has a friction loss of 25, that is the absolute best case scenario. I've never seen it. Not saying that there's not a length out there or 4 lengths out there, but somebody tested, and I think they had flow gauges that were not calibrated, inaccurate, because I haven't ever seen it. But they come up with a friction loss of 25 at 200 gallons a minute. Well, now they print it out for everybody to see, and so what we have is we have firefighters or officers that as a rule aren't very familiar with hydraulics. And they see it as an opportunity to lower their pump discharge pressure. So now if they want to flow 200 gallons a minute if they wanted to, and they understand that they're dealing, say, with a 75 PSI TFT nozzle, and that their friction loss total of 200 gallons a minute is only 50, well, then they're dealing with 125. They're going to pump 125 on 200 foot of hose. Well, the reality to that is when they don't have those 4 perfect lengths, and their friction, they get a length of hose, which, by the way, we took delivery of the day the chart came out. We got a delivery of a new brand of hose with a friction loss of 48 at 200 gallons a minute. So the reality of that is when you give best case scenarios as a rule, and firefighters believe it, what happens is the end result is a negative. Now we have people lower their discharge pressure thinking they're flowing 200 gallons a minute, and in reality they're going to be flowing less. And whenever they get worse hose, they flow less again. And the whole, 2 things on putting fires out. Water, number 1. Ventilation, number 2. It takes gallons per minute to put fires out. And today, more than ever in my career, it takes higher gallons per minute. Yeah, nobody should be entering, in my opinion, nobody should be entering a building flowing less than 200 gallons a minute on the hand line. And yet, we know this, and then we put out this information that if it is best case scenario, there's no reason to put it out to everybody because they don't understand it. They take it as a rule. Case in point. Can I expand on that?
Absolutely.
38 years ago when I came in, 38 years this June when I came in the fire academy, we were taught that the minimum size ventilation hole to cut in a residential fire was a 4x4. Minimum. That's what we were taught. That's still what they teach today, even though everybody agrees fires have changed. But the key there is that we were taught that it was the minimum size hole to cut. But that's not what it has become the standard. Throughout the country, it's become the standard. When you ask firefighters what size hole do you cut, they don't tell you the smallest we're going to cut is a 4x4. That is what they intend to cut, a 4x4. So irregardless of conditions, the size of the structure, they cut a 4x4 hole, which is way undersized for today's fires. Today's fires take higher GPM flow. And by putting this information out there, we're endangering firefighters. And hands down, you ask why my demeanor changed, and I feel like it's changing while I'm talking to you about it, is that my whole goal in my life is to keep firefighters alive on the fire ground. Teach them to be good firemen, the kind I'd want to show up at my home if my family was trapped. But to do that, you cannot teach best case scenario. We have to be pessimistic. We have to plan pessimistically, plan that we're going to be undergunned. We should always, my opinion, we should always be moving toward overwhelming the fire, cutting too big a hole, flowing too much water. Because when we do less than that, then we're allowing the fire to control us, to overwhelm us. And by putting this information out there, you're right, it infuriated me because it was so short-sighted of looking at the big picture. It's great to know that we have, the case in point, the ponds and aquaflow hose, friction loss of 32 versus 62 on the old hose. Great that we can now flow 200 gallons a minute pumping 170 on 200 foot. But you can't sit there and tell guys that that's a rule across the board because, again, different 1 3/4 hose will have different friction losses.
So if I'm a new EO or new officer and I just discovered this fact by talking to you today, what should I do to correct it? How can I dictate the conditions of the fire ground by maximizing my GPMs? What should I be doing?
To maximize your GPM?
Yes, I want to come out on the win on this fire. So
okay.
if the chart that we put out is setting me up for failure by giving me the best case scenario.
Correct.
What should I be doing to ensure my success?
Okay, well, I'm gonna put it out there. This is my opinion. First off, I'm a fog nozzle fan. I've been fighting fire. Well, imagine out of my 38 years, at least 30 of them were either on a nozzle or behind the guy on the nozzle. And so I have a few fires under my belt, and they were all done with fog nozzles. Pumping high pressure, even back in the days when we used 1.5 inch, only flowing 125. So I believe in flowing as much water as I can train my crew and myself to handle effectively. Doesn't mean it's going to be comfortable. I never thought of the water coming out of my hose as being comfortable, but I always thought of it as overwhelming the fire so that we got the fire under control and save lives and lessen the amount of damage. So I'm a fog nozzle fan, but hands down, when we talk about 2.5 hand lines, here is what happens with ponds and aquaflow hose. We have crews, we have chiefs, and we have officers that will pull 2.5 hand lines, big fire, big hose, and that's what they preach. And that made perfect sense back when I was a rookie. Back when I was a rookie, we used 1.5 inch hose flowing a maximum of 125, and our 2.5 with a fog nozzle flowed a maximum of 250. Today, a 2.5 fog nozzle flows a maximum of 250. Nothing changed. But on a 1.75 inch line, ponds or aquaflow, if I pump 200 pounds engine pressure and I put an 1.25 inch solid tip on it, this is the only time I would change tips. I can flow 325 gallons a minute and be able to handle it. It's not comfortable. It's not comfortable. You're not going to walk with it.
So when you say you were able to handle it, you as one individual to handle it, or as a crew you guys were?
No, I have a video I show of one rookie I had here that thought it was impossible, and he's not only handling it by himself, he's handling it at one point with no hands, because you have to learn how to handle nozzles. You have to learn how to handle hose. It means you have to go out and train and drill, no different than on how to cut. And I'm sure you're seeing my demeanor change. I'm sorry. But I'm passionate about this job, and you have to train and you have to drill. And even though this man came and where he came from, he didn't think it was possible. We had him in the back flowing 325 gallons a minute, literally with no hands. Now, on the video, you'll hear me very quickly tell him to put his hand back on the bale. But you have to know how to handle it. I had Christine Bailey at 51s holding 375 gallons a minute on a 2 inch by herself before I made her give the nozzle up. And that's because it started to creep. I had a firefighter probably wasn't 5'2" and 120 pounds holding 300. It's all about technique. Doesn't mean that you're going to walk with that line, but you're going to black everything out within 70 feet, if you had 70 feet, and you're going to black it out and overwhelm the fire, shut it down, and advance the line. A 2.5, very few crews, even though they'll tell you that, very few crews will consistently continue to move a charge 2.5. But when you ask crews about 2.5 hand lines and ask what GPM flow they're flowing, the answer you're going to get is 265 to 325. Except you can flow that on 1.75 inch. If you pump it right, you put the right nozzle, and you practice how to handle it. Then if you pull a 2.5, you attach a blitz fire to it and you flow 500. But those are my opinions. And
so, if, like I said, how do I get to those GPMs you said? Is there a way to verify how am I getting those numbers?
oh yeah, easy.
So,
a pitot gauge.
Pitot gauge.
A pitot gauge, well, you have to have a flow gauge when we're talking fog nozzles. But I'm not aware of any fog nozzle on 1.75 inch that'll, I can take a fog nozzle and pump it to get 260, but the pressure's way beyond what I'd want. So I try to find things that are within reason. We flowed one day 347 on 1 3/4 inches, but the pressure, it doesn't make no sense. So what we came up with, simply pumping 200 pounds of engine pressure, pump discharge pressure, 200 on 200 foot of ponds or aquaflow hose. Key here is you have to have an 1 1/4 ball valve. You have to have a ball valve as big as the tip, because your other ball valve is like a 15/16. So you have to make sure your ball valve is big enough. Put an 1 1/4 or an 1 1/8. Some guys use an 1 1/8, but an 1 1/4 tip, and you put a pitot gauge on the end of it. You can literally take a 2.5, pump that 1 1/4 tip till you get 50 pounds reading on your pitot gauge. 50 psi nozzle pressure on an 1 1/4 tip is 325 gallons a minute, no matter how you figure it out. When you get 50 pounds nozzle pressure on that 1 1/4 tip on the 1 3/4 line, your GPM flows 325. It doesn't matter what nozzle, what hand line you're using. When you get that X number of pounds of pressure on a solid tip and you use the formula, that tells you your GPM flow.
So what is that formula? Where does one find this?
Okay, I don't know where you can find it. I can tell you what it is.
Okay, tell me what it is. All right.
Okay, if you use a calculator, it's 29.7 times the diameter squared times the square root of your nozzle pressure. What I teach is the fire ground method, which you just use 30 times the diameter squared times the square root of the nozzle pressure. And so like 50 pounds, I use 7 as the square root. It's the square root of 49. So we fudge a little bit there, but it comes out only a gallon or two one way or the other.
Right.
But it's technically 29.7 times the diameter squared times the square root of the nozzle pressure, or you can use 30. And that's going to tell you how many gallons per minute at so many pounds of nozzle pressure you're getting off of that tip. And that's how they calibrate flow gauges. They use a solid tip because you get X number of pounds at so much pressure. And so you can do it on an 1 3/4. You can flow the exact same water that somebody on a 2.5 next to you is, except that you have maneuverability. Here is the only negative. And what people will invariably tell you when I talk about an 1 1/4 tip on an 1 3/4 line, they'll tell you that it breaks the rule. The old rule was that you do not exceed the diameter of your hose by more than 1/2. So 1 1/4 is more than half of 1 3/4, obviously.
Correct.
And so the reason for that rule and the way it worked was that they grade the quality of a stream. They shoot water, and don't hold me to the exacts, but they shoot water through an 18-inch circle. It's like 70 feet away at a 35-degree angle. It may be 75 foot away at a 30-degree angle. I don't know. I learned it back when I was a rookie 38 years ago, so the numbers may have be skewed a little bit. But here's what they do. They shoot it through this 18-inch circle, and in order for a stream to be graded good, 90% of the water that comes out of the tip of that nozzle has to go through the circle. 90% of the water for it to be good. Well, whenever I put an 1 1/4 tip on an 1 3/4 line and I flow it pumped at 200 and a 2.5, I have them both flowing 50 pounds nozzle pressure. No doubt the 2.5, the stream is prettier. It goes about 30 to 40 foot farther. It holds together farther. But then my question always is, how many fires has anybody fought through an 18-inch circle? That is, in my career, I know of none. Most of my fires, almost all of them are at some point going to be up close and personal. I'm not worried if I lose my water out at 100 feet. I'm worried about what's coming in 20, 30, 40 feet. And I'm still getting that 325 up close, but I have maneuverability. And all you have to do is do it in your backyard. Or you go out there, do it, set up some obstacles and get your best crews. and see who moves what line the most. The total number of gallons per minute that are applied on the fire is always going to be the 1 3/4 when you do it right. There's still a place. 2.5 still is a necessity on high rise. And that's simply because we can't control the pressure. On a PRV system, we cannot pump into the system and increase the pressure. But as far as a line on a fire ground, if I'm having to handle it, the only way I want a 2.5 is with that blitz fire attached, so at least I get a break in between handling the nozzle. And then you flow 500. So again, my opinions, but when I see these chiefs that consistently call for 2.5s, I'm pretty much remembering that they don't remember what it felt like to pull one.
Right.
Because it just doesn't make sense anymore. That's an old rule that's never been changed, the big fire, big hose, because now you can flow the water with, if that's what they're wanting, 265, 325. Otherwise, pull a 2.5, flow 500, but then put a blitz fire on it. So
The blitz fire, you're talking about the ground monitor, correct?
right, that's
Okay.
right.
Well, I think that's all I can ask. Unless you want to add anything else, I think we covered quite a bit. Or we can save it for another day.
Yeah, I know. I've got opinion. I think I voiced my opinions on hydraulics.
Well, we'll cut it here. How's
Okay.
that? All right, guys. I hope you answered all your questions. Once again, it's David and host Captain Jenkins. A well of knowledge. Thanks for watching. Post your comments. Let me know what you thought. Or if you have any additional questions, I'll try to get them next time. Thanks. Thank you, Captain Jenkins.
No, thank you.